Good afternoon, everybody, and welcome to our today's webinar, Modern Data Architectures in Azure and Microsoft Fabric, Building for Agility, Scale, and AI. My name is Shean McManus. I'm Field CTO, representing the Modern Apps and Data Intelligence practice here at Netrix.
Yep, it's good to see everybody again. My name is Tom Lilly, Field CTO for Cloud Solutions here at Netrix.
Glad to have you all joining us today. If you've missed any of our previous webinars, links to those can be found in the show notes for today's event. We did one a couple months ago on modernizing data and building a foundation for smarter decisions, kind of an overview of data practices in the cloud. And most recently, last month, we did a companion to this particular webinar on the AWS stack. So check out those if you're interested. Moving on to today's agenda, we are going to cover some data basics, and then we're going to hit details on both the Azure data engineering stack and Microsoft Fabric before doing a brief comparison between the two, and then talking about finally how you can get started on next steps for your own organization. So taking an initial step on data basics, briefly what we're talking about when we talk about data engineering is basically this type of a workflow here where you take data from any number of data sources on-prem, cloud, can be structured data, not unstructured data, and you go through a series of ingestion and data prep or data transformation processes here. The result of all of that usually lands your data in some sort of data warehouse or data lakehouse. And the idea being that that data warehouse, data lakehouse is a model, a gold layer model that you can run your business analytics on, run your machine learning algorithms on, and write reports off of. So when we talk about data engineering, this is what we are talking about from a very high level. Going forward, I mentioned gold layer before. Medallion architecture is really the common term now to represent an incremental structure of your data layers. And so that the idea being that your data will go through a series of transformations and improvements to take it from raw layer, which is often denoted as bronze, up to your gold layer, which is your aggregated and semantic model layer, or sometimes referred to as presentation layer. You can think of the gold layer is the layer that is most customer or business customer facing, and that is used to run all of your reports. And then that layer in between, which we refer to as silver, sometimes it's multiple layers, and that usually contains all of the data cleanliness, the data transformation, and different processes along the way. So I'm going to turn it over to Tom. He's going to talk a little bit about how data architecture works on the Azure platform.
Yeah, thanks, Sean. I appreciate it. So what we want to talk about in this section is really if you're going to build your own data platform and you're going to leverage native Azure services to do so, what does that look like? What are some of the tools available? What are some of the resource types available? And we want to talk about it in 4 different areas. Talk a little bit about data storage. So John was just talking about, everything from gold all the way up through, from bronze all the way up to gold. And then how do we get the data in there using like ETL tools? How do we get some real-time analytics in there? How do we overlay AI, machine learning on top of that as well? I do want to state that we also are going to be talking about Power BI a little bit later. Sean's going to focus on that when we talk a little bit about Fabric, because that is a core component of Fabric and really Microsoft's Power Platform in general. So we're not really going to cover that here in this section. We're going to focus more on the other 4 boxes as well. The other thing to keep in mind is that the solutions we're going to be talking about here are not the only ones available. We'll talk about some alternatives as well as we get to some of these too. But what we see here is not the only sort of capabilities that we have from an Azure perspective. And that is one of the overarching themes that you'll see when we're talking about these Azure services is there's a lot of different ways to make it work. There's a lot of different, ways to skin a cat, for example, that you as an organization can choose to leverage over other resources if they make more sense from a pricing or functionality or speed perspective. So with that, let's talk a little bit about storage options. So obviously, data storage is very important as we get into any sort of data estate and data architecture. When we start to talk about things like unstructured data and just petabytes and petabytes of different files and different pieces of information that need to be stored, we really like to talk about Azure Blob Storage. So Azure Blob Storage is really going to be that area, that storage account itself, that's going to host all of that information in a flat namespace. And that's really the important thing to understand, is that blob storage in Azure by default is going to be a flat namespace. So it's going to allow you to store all that unstructured data, to be able to find it and transform it very easily. Also, depending on what you want to do with that, you can also have rules in place that will remove data after a certain amount of time. If you have any sort of governance concerns or configurations or requirements, you can tier that data into other tiers. So you can take it from hot to cool to cold, all the way into archive, which is offline storage. That allows you to save money where you don't necessarily need to pay for it, and at the same time still maintain access to that data on a regular basis. Now, if you want to deploy a true data lake on top of a storage account, that's where we start talking about Azure Data Lake Storage Gen 2 or ADLS Gen 2. So this is going to take that flat namespace and allow you to deploy then a hierarchical namespace and hierarchical storage for that big data analytics. So for, once again, being able to get those petabytes and petabytes of data into the cloud and into this data workflow that Sean was just talking about as part of that medallion architecture, ADLS Gen 2 or Azure Data Lake Storage Gen 2 is really that first level and that first area where we're going to start working in data lakes. That's going to be the initial landing zone for a lot of the data that you're going to ingest through some of the things we'll talk about here in just a minute. And it could also be a target for some of your data hygiene and data cleansing as well, depending on how you choose to work with it. Now, getting into more relational data, so if you have, relational data stores more akin to like a data warehouse or a data mart, that's where we start to get into solutions like Azure SQL Server. SQL Server comes in many different flavors in Azure. Yep, we have SQL Managed Instance, you've got SQL on VMs, but the one that we see a lot for our data storage is Azure SQL PaaS. Or SQL Platform as a Service. And what this means is that the SQL Server itself is being run, maintained, managed, patched, secured, et cetera, by Microsoft as a platform service. And then you are free to bring in databases, bring in your own tables, obviously bring your own data, whether it is from some sort of copy job, whether it's an ETL pipeline. That data can then be stored in that server as a SQL-based relational data store. So if you and your teams are very familiar with transaction SQL and how Microsoft SQL Server works in general, this becomes a great solution for you to leverage and to be able to store that relational data. Now, for those that maybe need a little bit larger scale, or you want to get away from SQL, or you want to go to more document-based record sets, then we have solutions like Azure Cosmos DB, which is a globally distributed NoSQL database that does allow multi-region reads and multi-region writes. So for those of you who do have a globally distributed presence and you have the need to have multiple teams or multiple data sources writing at the same time in those different regions, Cosmos DB does support multiple different mechanisms of consistency, meaning that you can read and write from a lot of different locations, and the data is guaranteed to match and become eventually consistent, depending on how you set that up and how strict that is from your environment. So that does become a great option for those large NoSQL databases. We also have the ability to do things like managed MySQL, managed Postgres, a lot of other managed database solutions as well for data storage. But the four that we have here on the screen are generally the four that we see for most of our clients take into account when they're building their data estates on the cloud. So with that, let's talk a little bit about ETL or ELT. For those of you who are not familiar with it, ETL is extract, transform, and load. ELT is extract, load, and transform. A lot of it just depends on how you choose to operate as an organization and how you choose to clean your data. So for example, I may want to extract data from my ERP system. I'm then going to have my ETL tool make changes to that data. I'm going to have it, look for null values or, maybe data that doesn't need to go into the data warehouse, and then it's going to be loaded into that data lake or data warehouse, whatever that target is. The other side of that is taking all that raw data out of my data source, once again, that ERP system, for example. I'm then going to load it directly into my data lake. And then I'm going to have another process that's going to transform that data. That's going to run all the hygiene. That's going to normalize it. That's going to get it ready to go into some sort of relational data store or whatever that target does end up being. From an ETL perspective, we usually start with one of the core services for ETL, which is Azure Data Factory or ADF. This is a cloud-based and fully managed Microsoft solution that's got nearly 100 or probably over 100 at this point built-in data connectors to external data sources. This can be cloud-based sources like REST APIs, could be on-premises data sources like SQL servers, for example. It could be any native integration through, for CRM, ERP, whether it's, Salesforce Dynamics 365, et cetera. This data factory has these capabilities and these connectors natively built in. You don't have to do any sort of custom coding to make them work. But if you do have systems that aren't natively integrated, you can do custom connectors, you can do custom data flows and custom data ingestion as well. These data factory pipelines are meant to orchestrate and automate the collection and the transformation, the loading of data into your data estate, and they do it very well. And because you can configure all these individually, you can set up different schedules, different transformation rules, different requirements for all of your data sources to get that data into that data estate. So for example, if I have my sales systems, if I've got my CRM or HRIS platform, if I've got other, internal, line of business applications that I'm extracting this data from into my data estate, all those are going to have different requirements for maybe the frequency that data has to be collected, or maybe the type of data that has to be collected. So all these data factory pipelines themselves can be configured individually to optimize or to be optimized for those individual systems. And all those can be on different schedules as well. This is all done through the Azure portal, so you don't necessarily need to know a lot of coding. If you really want to, there are ways to make sure that this is stored and configured and maintained through code as well. But from just a general starting perspective, it's a great way to get your feet wet with ETL jobs in general. Sure. The next level up from that is Synapse Analytics. So I mentioned SQL Server on the previous slide as a data storage mechanism. Synapse Analytics can be layered on top of Azure Synapse for data warehousing that can provide analytics. So it's leveraging some of that transactional SQL language, leveraging Spark integration, for example, to be able to get to extract salient points from the data that's being stored in those data warehouses. If you have the need for real-time metrics and real-time reporting, you have that ability as part of Synapse Analytics, even though we're going to talk a little bit about real-time here in just a second, for other mechanisms to be able to get some of that real-time data out of the environment in real-time analytics. Because it is a Microsoft service, it also has native integration with Power BI and other aspects of the Power Platform. And just like Data Factory, it also has the ability to ingest data from multiple different sources. We're not just looking at data that's in, Synapse, for example. The important thing to keep in mind with this is, once again, this is a fully managed Microsoft solution. There aren't any servers to patch. There's no underlying security to maintain. It's really just building all of your analytics on top of Synapse as that platform, and then leveraging that as expected for, building your reports or building your analytics and things like that. For those that have more maybe experience on the data analytics side, we also offer Azure Databricks. This is a fully managed Databricks solution that integrates natively with Microsoft services like ADLS, like Synapse, like Power BI, that allows you to build your Spark notebooks and do Spark-based analytics on top of this data that's being stored. If you have a team of data engineers and scientists that all want to collaborate in a single workspace and work with each other, this gives them that area to be able to do so on these Databricks clusters that can be overlaid in the environment. Uh, we're going to talk a little bit later also about machine learning and AI Foundry and some of those capabilities. But once again, if you kind of want to bring your own modeling, if you want to bring your own compute infrastructure, Databricks is also a great way to do that as well, and ingest all this data, once again, terabytes or petabytes even of data, and optimize, process, and give you some information that's usable out of these solutions. So when we start to talk to our clients about building ETL pipelines and building their, transformation and their data promotion, things like that, these are a lot of the tools that we tend to talk about. That being said, some of the other ones that you may also hear of are things like Azure Functions and Azure Logic Apps. We do have some customers who are electing to use those solutions for ETL as well. They are a little less friendly from a configuration and a coding perspective, but they do offer a significant amount of flexibility as well. So I did want to call those out too. That if you do want to do something a little bit more flexible or less out of the box, those are some other options. But we do highly recommend to our customers, as we're talking about data, to focus really on these solutions to start. Primarily Azure Data Factory, because it does give you the easiest integration with your data sources. Now, we were talking a little bit about real time before. For a lot of our customers, especially in the manufacturing vertical and in sales, real time reporting and real time data is exceedingly important because you want to make business decisions with as little lag as possible. So with that, we usually like to start with event hubs. So event hubs are really just used for multi-partitioning and being able to take data and move it from one system to another. So for example, you can have an event-based system where it's you've got your sales system that whenever an order comes through, it sends a piece of data into a webhook that then goes into an event hub. The event hub is then going to route it into the appropriate system, maybe do some basic tasks against it as well. But it is meant for that real-time analytics. It's exceedingly scalable depending on how many events per second you're sending from multiple different systems. You can set up different partitions if you have different use cases, for example, for different event hubs. And in that mechanism, it allows you to also, once again, separate that data out, land it in different locations, maybe land it into a pipeline for, for future changes, et cetera. Eventually moving it into that data lake, into that ADLS, as we were talking about before, or into just general blob storage, depending on what your requirements are and where that data needs to land. One step up from that, we also have Azure Stream Analytics. So once again, this is going to give you real-time streaming data processing. For those of you who are, once again, very familiar with SQL language, so structured query languages, it uses a very SQL-like language, so you can take some of that experience and some of that knowledge that you've gained over the years and apply that into Stream Analytics for, once again, things like data transformation, to make sure that everything that's coming in is properly formatted to go into the environment. This does support output into many different services. Once again, the big ones that we do generally see are going to be in that data lake and data warehouse. And for those of you that are looking to do machine learning, we have direct integration with Stream Analytics from there as well. Although, once again, talk about that here on the next slide. For those of you that are running large Internet of Things environments, so once again, we see this a lot in manufacturing. Connecting and managing and streaming data from your IoT devices can be done using Azure IoT Hub. The big difference between IoT Hub and the other two real-time analytics solutions that we've talked about already is that IoT Hub isn't just a data gathering platform. It's also a platform that can be used to manage these devices. So if you want to make sure that they're secured properly, if you want to make sure they have the newest configuration, all that is also centralized from IoT Hub. So that sort of becomes that centralized hub, for lack of a better term, that you can use for your entire IoT infrastructure. So once again, sending commands down to your IoT devices, collecting telemetry to see how utilized they are, make sure they're still online, make sure they're still gathering what you're expecting, and then once again, receiving that streaming information from those devices as well to once again bring that data into data warehouse, into a data lake, maybe send that directly into Stream Analytics and have Stream Analytics do its work as well. There are a lot of different things that you can do with that IoT Hub to better understand and utilize and leverage your IoT infrastructure to get that data and get usable data out of it for, once again, all of the data estate and things that we're going to be talking about is, why you need all this information. Finally, when we start talking about to our customers about data estates, it always comes down to AI and machine learning. Most organizations that we talk to, maybe all organizations we're talking to at this point, have some sort of AI charter that they're trying to get either from their board or from their executives, or in some instances, even from the ground up, from the people who are working in the trenches and on the front lines for these organizations. So when we talk about AI and machine learning, there's two major areas that we like to talk about on the Azure side. Now, we're not going to talk about things like Copilot Studio. We're going to talk more about native Azure services like Azure AI Foundry, which becomes sort of an AI hub. It becomes that platform, that unified development capability and area where your users can go in and choose models and help to fine tune them, to deploy new models, to ground them in your data, to be able to make them available through other services as well, whether that's through chatbots or web apps or other Azure services, including things like Teams chats, for example. This AI Foundry has a significant number of models that are natively available in that catalog, including the new GPT-5 that was released just prior to this webinar. So as we get into having to build these models and use some of these new models, AI Foundry becomes that place for you to overlay these large language models over your data and to be able to use natural language to talk to your information, your data, about how it all works. For those that need a little bit more fine-tuned usage and you want to look more for machine learning and less against generalized AI and these large language models, Microsoft also has Azure Machine Learning Studio, or Azure ML Studio. This allows you to deploy training clusters with your own ML models. It also can integrate with some of the other services we've talked about previously, like Databricks and like Synapse, to once again integrate into your machine learning models as you are, once again, training them and fine-tuning them and deploying them, and having that full life cycle. As you are getting into things like MLOps, for example, ML Studio becomes that centralized location for you to deploy your own machine learning into your environment and then train and inference and all the other things that get into machine learning platforms in general. So as we talk through all of these, hopefully that gives you an idea of what Azure can bring to the table, but on the downside, it can also be very complex. Once again, all the solutions we've talked in the last 4 slides, as well as ones that we haven't even discussed yet, are all available to you, and sometimes finding the right one can be very difficult. So with that, I'm going to turn it back over to Shean to talk about the Microsoft Fabric platform, which helps to unify some of these services. So Shean, back to you.
Thanks, Tom. So Microsoft Fabric is, in essence, a brand new platform. Well, it's brand new. It's within the last couple of years it was released, but it's attempting to bundle all of these services together under a single common user-friendly interface. And so you'll see in here these top 7 or 6 or 7 workloads here that are core to Microsoft Fabric. They all have companions in the Azure framework. And in fact, in a lot of cases, the mechanics under the hood are exactly the same. And you can run Data Factory in Microsoft Fabric, and that's the same Data Factory code that's being run in Azure. So a lot of that is basically rebranding and putting on a brand new package. But in doing that, what you get is you get a very nice user interface. You get unified controls and unified workloads, and in a way that makes it a lot easier to digest and consume. So in the next few slides, we're going to go through these in some detail, and then we'll finish up with a compare and contrast. So first of all, Azure Data Factory, that is essentially your orchestration. That is essentially inside of Microsoft Fabric. So you can think of it as being your source for making connections out to external data sources, your mechanisms for doing design transformations. So those transformations can be done using low-code tools such as data flows or pro-code tools such as PySpark notebooks. And we'll talk a little bit about that more in the data engineering section. Data Factory allows you to create these pipelines and schedule them to run on certain triggers. So that might be new data showing up in a specific location, storage location, or it could be on a specific time schedule, like 4 a.m. every day. We kick off this ETL pipeline, and it's going to orchestrate and run all of the data ingestion and transformations we need to execute in that particular day. On data engineering, again, that is really, you can think of that as the analog to Databricks or to Azure Synapse. And essentially what that allows you to do is to set up Jupyter-style notebooks that support a wide range of coding options. So that can be PySpark, that can be SQL, Scala and R. And all of those different coding options are available inside of those notebooks. Notebooks have the other additional feature of allowing for interactive data exploration. So you are running and bringing in code into these notebooks. You're creating in-memory data frames, and then you can interact directly with those data frames, create visuals. Sometimes that is an effective development tool to understand how you're going to proceed. And in some cases, those notebooks can be generated as part of your output that you're going to present to business users. So it depends on the use case, but it offers a lot of flexibility and a lot of options in how you are going to transform your data to get from that bronze layer to that silver layer to that gold layer. On the data warehouse side, that is a relatively new offering in Fabric, which is a companion to the Lakehouse. You can think of Microsoft OneLake as supporting both, the Lakehouse being germane for unstructured data. So it will give you a file structure that will allow you to bring in files to allow you to create shortcuts out to your Azure Data Lake storage. And then the data warehouse is more akin to a structured SQL database. So having that embedded inside of Microsoft Fabric allows you that SQL and TSQL compatibility. So one can think of this as being something where you're making a migration inside your organization, but if all of your skill level and all of your personnel are used to working on SQL servers, and so they're heavily invested in writing SQL queries and SQL stored procedures, you can do most of your transformations using that code stream, and you can leverage data warehouse to be able to do that. Under the covers, that data is stored in a Delta Parquet format, and the benefit to that is that supports ACID transactions, it supports schema enforcement, and it even supports time travel. So you get all of those native benefits with your data stored in that format. Finally, cross-database querying, that allows you to be able to query information that exists in multiple databases without any performance hits. Similar to the AI and ML models and resources in Azure, the data science workload inside of Fabric allows you to do all of those same things. It allows you to create your data science models. It allows you to do testing, problem formulation, data discovery, all of that work inside of notebook type structure. So again, that brings into play that PySpark language, that brings in Scala, Spark, and SQL as potential options in there for integrated tools. The other neat feature of the data science workload is it allows that Power BI integration, which using a feature called semantic link, it bridges that gap for data scientists and business analysts by allowing you to access Power BI semantic models directly inside of the data science workload inside of Fabric. And as Tom mentioned earlier, real-time intelligence, definitely something that you see a lot with manufacturing clients and in particular with sales. The real-time intelligence options inside of Fabric provides you a centralized hub and a centralized catalog for managing all of that data in motion. So it integrates with the Event Hub in Azure and allows you to be able to do all of those event streams and process that data end to end in one place. So you can basically set up your Power BI workspace and Power BI dashboards to be updated in real time as conditions change. We had a customer last year that set this up in their manufacturing facility, and they were basically taking real-time data off of their manufacturing tools and ingesting that through event streams into Fabric, processing that data in real time and surfacing it to a real-time dashboard inside of Power BI. And then what that did is that allowed them to more quickly identify potential anomalies or defects in their manufacturing process. The next step on that too is to be able to layer on AI-powered tools and automation. So you can imagine that scenario that I was just speaking of. Now you're going to put an AI engine on top of that and potentially allow AI to be able to make those determinations on whether or not you have some anomaly in your manufacturing process. And finally, let's talk about Power BI, because Power BI is really the linchpin of all of this. This is going to be your analytics platform for whether or not you're using Azure or whether or not you're using Fabric. And Power BI is really, it's the world's leading business intelligence platform and has all of these native features in it that are make your analytics life so much easier. The direct lake mode here in Fabric will allow you to do high performance queries. It essentially obfuscates some of that refresh that would be typically done in the past in Power BI and makes that performance so much more quick. So if you have an instance where you're currently having to set up refreshes in your Power BI data sets, by utilizing Microsoft Fabric and that direct lake mode, you can streamline that process and give better performance to your business users. Power BI also supports native integration with the Microsoft 365 platform, native integration with Git, and more importantly nowadays with Copilot. So imagine a scenario where you want to be able to have your business users writing natural language queries against your semantic models and against your data. In Power BI, that is possible now. You can be integrating and interacting with Copilot and asking specific questions of your data, and not necessarily having to rely on your BI team to be able to set up the reports to get those answers you want. You now have the ability to be able to ask that of your data itself. And so that's a very powerful feature. And we're seeing a lot of interest in that with our clients. Finally, Fabric provides a centralized governance across all of workloads, and that includes Power BI. So features like data lineage, like sensitivity labels, impact analysis, all ensure a secure and compliant managed analytics solution for you. So we mentioned Copilot here in the last slide, but Copilot in Power BI is not the only place where you see that embedded inside of Fabric. Copilot is also available in ways that allow you to interact with it and help you with code completion, generating of prompts, and also throughout the course of building out notebooks, assistance with doing debugging and troubleshooting. It's a very powerful way to leverage that AI prompt without having to leave the confines of Fabric and be able to interact directly right there with your code and with your notebooks. It also allows you, as I mentioned before, in Power BI, report creation assistance. So that's the case where you're not just asking for a specific answer for your data, but you want to be able to generate a new report that's going to look a certain way and provide this type of information and certain details. Very powerful tools now available. And I should mention, as of this spring, Copilot is now available inside of Microsoft Fabric at all SKU levels. Prior to April, I think you needed an F64 in order to be able to leverage the Copilot features. They have now dropped that, and so Copilot is available throughout all SKUs in Microsoft Fabric. OneLake. So OneLake, Microsoft likes to talk about this as sort of the one drive for your data. So it's a single place that really federates out all of your data. By leveraging shortcuts, you have access to Azure Data Lake storage, you have access to structured data and unstructured data throughout a myriad of SaaS lakehouse sources that are available out there through both Azure and inside of Microsoft Fabric. And those shortcuts really just make it so much easier for you to be able to interact with that data, start transforming your data, and to be doing data virtualization. Very powerful and integrated feature in Microsoft OneLake. And finally, the security, governance, and admin features in Microsoft Fabric allow you to manage and secure all of your data. This is all done in conjunction with Microsoft Purview. Microsoft Purview, again, a leader in that industry, which provides you with all of the data governance and all of the features you need, sensitivity labels, DLP, audit logging, all of that information that gets you to set up your data and set up your structure in a way that is safe and secure. Another thing that I would mention along here with security, it's not specifically a feature of Purview, but the Fabric data sets support data segmentation. So that's things like row level security and column level security in your data sets. You can segment that out using role-based access control. So only certain roles in your organization get to see certain columns or certain rows of data based on whatever your business rules might be. So Azure or Fabric, that's the question now we're going to try to tackle here. We're going to do a little bit of a comparison here. I'll bring back Tom. He's going to talk about the Azure side, and then we'll maybe start with a little bit of a conversation that can talk about companions Azure to Fabric and what might be the differences between the two and how you can use those to help make your decision.
Yeah, absolutely. As I was talking about before, and hopefully from what you've seen over the last handful of slides, the biggest differentiator for Azure is that it really is a build your own environment. All of the individual components have to be deployed, on their own. They have to be configured on their own, secured on their own. You can make that easier using some infrastructure as code tools and other things like Azure Policy. But at the end of the day, you are still deploying everything individually. Now, the other potentially good thing about that is that also means that all of those components are also priced individually. So from a storage perspective, paying per gigabyte of data stored in your storage accounts, paying per execution time for functions or for your ETL pipelines or amount of data processed or things like that can also be very advantageous for organizations that want to get some very granular costing and billing out of their Azure environment and out of their data estate in general. So having that sort of some of the individual costing components is certainly a benefit. It is also a downside if you're not used to monitoring and managing and doing your own cost analysis, especially if you haven't really adopted solutions like FinOps into your organization. That having all of these things in their own sort of billing buckets can certainly be very overwhelming for some teams. But the other nice thing about having all of these separate components is also it's a lot of flexibility. You can size some components up or down as needed for you to have the performance you need or maybe the price point that you need. You can leverage any service in Azure that you want to be able to do some of the ETL jobs or data storage or data presentation, for example. And then, the biggest thing is, especially for smaller environments, we found that, if you only need, 3 ETL pipelines to run every day, and you're only storing, 2 terabytes of data in your data lake, or, in your data estate in general, that some of these consumption-based metrics and some of these Azure services can be a little bit more cost-effective than, buying everything together as part of a Fabric capacity SKU. So there are definitely ways that Azure can, call it, win, or maybe more advantageous for you to deploy in your environment. But that's not to say that Fabric itself is not a great solution in a lot of different ways, which Sean is going to wax poetic about here for a few minutes. But Sean, what do you got to say?
Yeah, I mean, Fabric is the newer version of all of this. So Fabric is the tool and the platform that Microsoft is putting money against right now, and development time and effort. So if you want to get on the latest and greatest and see where Microsoft is going with this, then that's really is Fabric. And that concept of an integrated all-in-one solution where you have all of these various workloads that are under the same UX umbrella, that is something that's very attractive to people. It gives developers a single place to go to do whichever workload they need to do. And in a lot of cases, the unified pricing that is, you pay for that particular compute SKU, and you pay X number of dollars per month based on whether or not you're getting an F2 SKU, an F4, F8, on and up. So you have really some very good price or cost certainty there with your Fabric environment. So cost certainty, all-in-one solution, unified workspace. Additionally, that one lake integration is key. And we didn't talk about this earlier, but Fabric supports SQL mirroring. So if you have an Azure SQL database out there, you can mirror that data into Fabric, and if you get the same, you get 1 terabyte of free mirroring for each compute SKU that you have in Fabric. So if you have an F4 compute SKU, you have 4 terabytes of data that you can mirror from your Azure SQL database directly into Fabric. And what that does is that eliminates the need to set up additional ingestion jobs for that data. That data and those tables are just right there, and now you're already often running on your transformation layer. And then finally, obviously, the Copilot integration is another big plus on the Fabric side. Something that you can build AI integrations into the Azure side, but it's not baked in, and it's not as neat and easy to use. So some of the things about Fabric that we just love and we're seeing our customers be very interested in right now. And with the flexible SKU options that Fabric has, you do have some SKU levels that are priced very competitively. And going forward, if you are set up where you believe you have that right SKU for your needs, you can purchase a reservation on that and then achieve even greater cost savings. So there's a little bit of flexibility there to kind of have a little bit of that hybrid model in pricing that you might have with Azure as well.
Yeah, and I think one of the things that I also want to mention that, Sean, you talked a little bit about this earlier, but I think is also important to call out here is that we're not necessarily talking about one or the other. There are a lot of situations where maybe you want to do the bulk of your data storage and data transformation in Fabric, but you need to go very custom for a very specific use case, and therefore you're going to deploy ADF, Azure Data Factory, to do that for you as an Azure resource. Or maybe you want to deploy an API that retrieves data or receives data, and then can then send that into Fabric. So when we're talking about Fabric or Azure, it isn't just going to be one or the other. In a lot of situations, and what we're seeing a large number of our clients move toward is that hybrid model. Is it's leveraging both in some way, shape, or form. I don't know, Sean, if you have anything to.
Yeah, I mean, certainly with Fabric, we do see a lot of solutions where Fabric is utilizing the storage options in Azure under the covers and just using the shortcuts available in OneLake to bring in that data, or the SQL mirroring. So that's one place where those services definitely overlap.
Yeah, absolutely. And Microsoft's trying to make that as seamless as possible with, tools like mirroring, as Sean was mentioning, that they realize that, one, they want people to be able to use, Fabric as a platform, but two, they want to make it easy to move and to start leveraging it without having to undertake a massive data migration from one platform where, maybe you've spent a lot of time and money and effort and blood, sweat, and tears and standing up. Um, you know, so how can we ease that transition to getting into this new platform and sort of the new way of working? I know that Microsoft has spent a lot of time figuring out how to make that work using like mirroring, for example.
So next steps, this is how we recommend that customers get started on this. Start identifying business cases in your environment. We like to say develop that business case from a pilot perspective, and start small. Consider the ROI. That's a big benefit when you're trying to make this business case up the chain in your company. Is figure out what are people doing right now. Are they leveraging this data right now, but it's taking a manual effort to do that? In that case, you have man hours that are being saved by being able to use these tools to automate your processes. Perhaps you don't have anything in place. Then you can look at, well, what is the benefit of having this data and having these analytics inside of Power BI? Can I leverage that to make more informed business decisions? And there's an ROI calculation available on that if you're able to make that case. So consider the ROI, determine your architecture. Start thinking about whether or not you want to go with maybe a single layered approach with Azure or Fabric, or maybe a hybrid approach. Like I mentioned earlier, develop a pilot project. Start thinking about how you can start small, crawl first, crawl before you walk before you run, that sort of thing, and build out your process in layers. And again, to that, learn, iterate, and expand. A data platform is not something that is just built and left alone. It's something that can continually be expanded on. And as you bring in new data sources and new analytics to inform your business decisions. So to that end, if you are needing any help on this is how Netrix can help. We have an engagement that we call a data platform jumpstart, and we will customize that engagement to help our customers get started in Fabric or in Azure Data Factory or in Azure, and we can help you set up those pilot projects that incorporate the whole wide range of data ingestion, data transformation, and visualizations. We will scope our engagement to your needs. And if you're not ready to kind of jump all the way into that, we can do an assessment. We can do a proof of value. We can analyze what your use case is and figure out what the best approach would be, the best roadmap going forward for you. So if you need some help, feel free to reach out to us. Again, our contact information is right here. It's been great talking with you all today, and I hope you were able to get some great information out of this, and let us know if we can be of help down the road. Thank you.